Let's talk about analyzing population growth using differential equations. We're going to keep it simple, not going to do Verhulst's equation, for example. The population of a particular country is increasing at a rate proportional to the population. And this is standard. This makes sense because the more people you have, the more people you're going to add each year. So it seems reasonable. The population of the country is now 5.5 million. 10 years ago, it was 4.8 million. What will the population of the country be 7 years from now? Let P be the population of the country in millions. Let's say T is the number of years after that initial population census, so that P of 0 equals 4.8. So in other words, 10 years ago when the population was 4.8 million, we're going to say that's time T equals 0. And then P of 10 would be 5.5, because at time T equals 10, 10 years later, the population is 5.5 million. Okay, so again, the population of a particular country is increasing at a rate proportional to the population. This means that dp dt, that's the rate at which the population is changing, is going to be proportional to p. So it's going to be some constant times p. We'll say kp. Okay, this is a separable differential equation. So let's separate it. We have dp over p equals k dt. We know, so we've separated them. Now we integrate. Integral of dp over p, k dt. This is going to be the natural log of the absolute value of p equals kt plus c. When we integrate, p is always going to be positive. You can have negative people, but you can't have negative population. So this is going to be negative. So this is going to be natural log p equals kt plus c. We know what to do to isolate p. We raise e to both sides. We get e to the natural log p equals e to the kt plus c. We're going to break that up, e to the kt times e to the c. So e to the natural log p, that's just going to be p, because e to the x and natural log x are inverses of each other. As for e to the kt times e to the c is just going to be a constant. And so we're just going to call that constant c. Yes, I know it's confusing that we say e to the c is just plain c, but it's just a constant, so we'll call it c. So we have p equals c e to the kt, or in other words, p of t equals c e to the kt. Okay, so that's our population equation. To find c, let's plug in t equals 0. P of 0 equals c e to the k times 0, which is c e to the 0, which is just plain c. So notice, c, our constant, is just p of 0. So p of t is c e to the kt. In other words, it's p of 0 e to the kt. Sometimes we use p0, p sub 0, to refer to p of 0 because it's the initial population. So we can rewrite this equation as p of t equals p0 e to the kt. We know what the initial population was. That was 4.8 million, and since we're measuring population millions, p0 is just going to be 4.8. Okay, so we have our formula for p of t. P of t, the population in millions at time t, is going to be 4.8 e to the kt. You know what we need to do next. We need to find k. So let's plug in t equals 10 because we know the population at time t equals 10. We have p of 10 equals 4.8 e to the k times 10. But we know what p of 10 is. The population at time t equals 10 is 5.5 million. So we have p of 10 equals 5.5. That's 4.8 e to the 10k. Let's isolate the k. We have 5.5 divided by 4.8 equals e to the 10k. We'll take the natural log of both sides so we can get the k all by itself. The natural log of 5.5 over 4.8 is the natural log of e to the 10k. Again, natural log x and e to the x are inverses of each other, so the natural log of e to the 10k is just plain 10k. Lastly, let's multiply both sides by a tenth, or divide both sides by 10. We have 1/10 natural log 5.5 over 4.8 equals k. And when you plug that into your calculator, you find that this is just 0.0136. Okay, so k is 0.0136. We're left with p of t equals 4.8 e to the 0.0136t. Great, so now we have a formula for p of t. So that's our population. 10 years ago, the population was p of 0. Now the population is p of 10. The original question is, what's the population going to be 7 years from now? Well, if now the population is p of 10, 7 years from now, the population will be p of 17. So we need to plug in t equals 17. Here's our original equation for the population. Plug in t equals 17, and we get p of 17 equals 4.8 e to the 0.0136 times 17. Plug that into your calculator, and you get 6.048. We were only given things accurate to 2 significant digits, so we're going to round that to 6.1. So our answer is 6.1 million people. That's how many we'll have 7 years from now. When will the population of the country be 6.8 million? This is different. In the previous problem, I told you t, and you had to find p of t. Now it's the reverse. I'm telling you what p of t is. P of t, the population, is going to be 6.8. Let's find out what value of t yields that value of p of t. So we have, let's see. So yeah, let's get t all by itself. So divide both sides by 4.8. We have e to the 0.0136t equals 6.8 over 4.8. You know the routine. So to get t all by itself, we take the natural log of both sides. Natural log of e to the 0.0136t is natural log of 6.8 over 4.8. The reason we did that is because the natural log and e cancel with each other since they're inverses of each other, and we're left with 0.0136t, and that's just the natural log of 6.8 over 4.8. Divide both sides by 0.0136, and we get t equals natural log of 6.8 over 4.8 all over 0.0136, which is 25.6107. Again, we're going to round that to 2 significant digits, so we end up with 26 years. But that doesn't mean 26 years from now, because now we're in year 10. So t equals 26. That means 16 years from now. So 16 years from now, the population is going to be 6.8 million. If population trends continue, which admittedly is an unrealistic assumption.